In 7.2, we're multiplying rational expressions, and we have some steps for doing this. The first step is to factor out the numerators and the denominators. Once everything's completely factored out, I then write it as just one big fraction. If anything repeats in the numerator and the denominator, then we're just going to cross that out, and you can multiply the remaining factors, or you could leave it as it is in the factored form. But if we're going to factor everything out, I can write 8 as 2 times 4, but 4 is 2 times 2. So 8 is 2 times 2 times 2, right? X squared is x times x. Y is just y. 5 is already prime. Y squared is y times y. 30 is 6 times 5, but 6 is really 2 times 3. So 2 times 3 times 5 is 30. X cubed is x times x times x. Y to the 5th. Seven is prime. And then x cubed is 3x's. And we're going to cancel what repeats in the numerator and the denominator, because really 2 divided by 2 is 1, right? And 1 times anything is itself. 5 repeats. And then we have 1x, 2x's. We have 1y, 2y, 3y's. And we're left with 2 times 2 over 3 times 7 times x times y times y times x times x times x, which multiplies out to give us 4 over 21 x to the 4th y squared. So number 2, remember that first step is to make sure that everything is factored. 4a plus 8 has a GCF of 4. If you factor out a 4, you're left with a factor of a plus 2. And then we have a 3, which is prime. We have an a, which is just written as a. In the bottom, we have a cubed, so a times a times a. And the 6a plus 12, we can factor out a 6 and would be left with a plus 2. And then for that 6, just know that that can be thought of as 2 times 3. And that makes me think about this 4 up here. 4 wasn't prime. That can be thought of as 2 times 2. So things that repeat in the bottom and the top. The factors of a plus 2, a factor of a factor of 3, and it looks like I also have a factor of 2. So in the numerator, I'm left with 2. In the denominator, I'm left with a times a, which is 2 over a squared. Okay, on number 3, the 9 minus a squared, I was thinking about GCF. There's not a GCF, but that's a minus sign, and 9 is a perfect square. 4a squared is a perfect square, so that can factor into a difference of squares. And then the 4a, just remember 4 is 2 times 2, and then you have a. So I'm just going straight across. And then in the bottom, 4 a minus 6. You can take out a 2. You will be left with 2a minus 3. And the trinomial of 2a squared plus 5a plus 3. You're looking for what multiplies to give you 6 and what adds to give you 5. So that would be 2 and 3, right? So if I go off to the side and rewrite that trinomial as 2a squared plus 2a plus 3a plus 3, I can then group it, pull out a GCF of 2a and be left with a plus 1, pull out a GCF of 3a, of just 3, excuse me, and be left with a plus 1. So that factors into a plus 1 times 2a plus 3. If we take out that GCF of a plus 1, that 2a plus 3 is what we're left with. So I'm going to write a plus 1, 2a plus 3. So right off the bat, what cancels? We have a factor of 2 that cancels. We have a factor of 2a plus 3. Now in the top it's 3 plus 2a, but notice our signs are exactly the same, so they will cancel. Now I'm looking at the 3 minus 2a and the 2a minus 3. If I rewrote one of them, if I took out a negative 1, if I factor out a negative 1, I would then have a negative 2a and a positive 3, right? Well, and so I rewrote that. Let me scratch it out. Now if I compare it to this, the 3 is positive and the 2a is negative. So they're the exact same, and I'm left with the negative 1. So my final answer, 2a over negative 1, I say it's my final answer, times a plus 1. There's several different ways I could write this. I could just put the negative out front, and I think that's what I'm going to do. Okay, with this one, the 7b squared minus 7, I can factor out a 7, and then would be left with b squared minus 1. But now b squared minus 1 isn't fully factored. That's a difference of squares. That's really b plus 1 times b minus 1. Okay, and then we have two factors of b plus 3, because b plus 3 squared means multiply it by itself twice. B squared plus 9 in the bottom is a difference of squares. The square root of b squared is b. The square root of 9 is 3. So looking at the 14b squared minus 14b, I can pull out a 14. I can pull out a b, actually. And do remember 14 is really 2 times 7. Anyway, if I pull out 14b, I would be left with b minus 1, which is really b plus 1, b minus 1. So I've done a good bit of scratching out. Let me rewrite this. So right off the bat, I noticed that the 7 cancels. I have a b plus 1, b plus 1, b minus 1, b minus 1. There's two b plus 3s up top, but there's only 1 in the bottom. And then I'm left with that b minus 3 and the b plus 3 up top. And I can't factor out, I mean, I could try to pull out a negative out of one of those, but it still wouldn't make the inside be the same. So I am left with b plus 3 all over 2b times b minus 3. And I would leave it in that factored form. So now we're going to look at division of rational expressions, and it's super similar to multiplication, because all I have to do, if we start off as division, if we have a rational divided by a rational, okay, so a fraction divided by a fraction, all I need to do is I need to leave the first fraction the exact same, and whatever you're dividing by, so the second fraction, you need to flip it. So originally it was r divided by s, but if I flip it, it's s divided by r, and the problem becomes multiplication instead of division. So on number 5, that means I would leave 4a cubed divided by 10a squared b the exact same. I would change it into a multiplication problem, and 5b to the 5th would be my new numerator, and a squared b squared would be my denominator, okay? So if I write the prime factors of all of this, 4 is 2 times 2, a cubed is a times a times a, 5 is just 5, b to the 5th, so now I'm going to cross out what repeats. Got a 2 that repeats. We have a factor of 5 that repeats. A, 3 factors of A, and a factor of B, so that we're left with 2b squared over A. So when I'm rewriting on number 6, I have my first rational is the numerator, and then the second is the denominator. So the numerator stayed the same. So if I had this divided by this, that numerator stays the same, and you flip the denominator. So whenever you flip the denominator, it changes it into a multiplication problem. So instead of having 7d cubed over 20c squared d, I just flipped that denominator. So now I'm going to write out the prime factors of everything. You have 2 times 7. Okay, and now 20 is 2 times 10, but 10 is really 2 times 5. And then you have c squared d, all divided by 5, c squared 7d cubed. So now to mark out what repeats. I'm marking out a 2, but 2 does not repeat. So draw that 2 back. I was just, kind of working ahead, thinking, oh, that usually marks out in the front, but it's not going to this time. 7 can cancel. A factor of C, a factor of C, a factor of D, another factor of D, another factor of D, the 5. So it looks like I'm not left with a denominator at all. I'm left with the 2 that I scratched out right here that shouldn't have been scratched out. C, D, 2, 2, C, C, D. So that is 8 C cubed D squared. So on number 7, I'm working on rewriting this problem to change it into a multiplication problem. That first fraction, the first rational expression is just going to stay the same. I'm flipping the second one, so that it will end up being x plus 2 over 4x. So now what I want to do, I want to make sure everything's completely factored. On the 12x minus 24, I can factor out a 12 and would be left with x minus 2. Just remember that 12 is 3 times 4 but 4 is really 2 times 2. So I could just erase that and say, instead of pulling out 12, I pulled out 3 times 2 times 2. And then, okay, and then the factor of x plus 2 right here, that does not factor at all. The trinomial of x squared minus 4 plus 4, the factors of a positive 4 that add to give you a negative 4, would be x minus 2 and x minus 2. If you fold that out, the negative 2's would multiply to give you that positive 4. They would add to give you a negative 4. And then we have the 4x. Just know that 4 is really 2 times 2. And then you have x. So what repeats? A factor of 2, another factor of 2, a factor of x minus 2. So we are left with 3 times x plus 2 divided by x times x minus 2. Okay, so on number 8, you can see that I've already rewritten the problem and changed it into a multiplication problem. So now I'm going to work on factoring everything. The 3m squared minus 27, I can pull a 3 out and be left with m squared minus 9. But wait now, m squared minus 9 is the difference of squares. So I can write that as m plus 3, m minus 3. Okay, the trinomial of m squared plus 2m plus 1, the factors of 1 that add to give me 2 are m plus 1 and m plus 1. M squared minus 2m minus 3, factors of negative 3 that add to give me 2, or negative 2 rather, would be negative 3 and positive 1. And looking at the 6m plus 18, if you factor out a 6, which that's really 2 times 3, right? If you factor out a 6, you're left with m plus 3. So let's look at what cancels. A factor of 3, a factor of m plus 3, factor of m minus 3, a factor of m plus 1. So it looks like all we're left with is m plus 1 divided by 2. So now we just got some practice problems. Just know that with this one on number 9, m plus 6 wasn't rational, but I mean, it's got a denominator of 1 if you need to see it like that. So we do want to make sure everything's factored out. 2m plus 1 does not factor. And then m plus 6 does not factor. I'm going to look at the trinomial of 2m squared plus 11m minus 6. For that trinomial, you're looking for the things that multiply to give you negative 12, because you got to multiply 2 and negative 6 together, but add to give you positive 11. So if they're multiplying to give you a negative, they're different signs. If they're adding to give you a positive, they are the largest number is positive. So if I did positive 12 and negative 1, that would add to give me 11. So let me rewrite the trinomial as a 4-term polynomial. I'll say 2m squared plus 11m, or excuse me, plus 12m minus 1m minus 6. Okay, and so that 12 and negative 1 add to give you that positive 11. Factor by grouping. In the front, we can factor out a 2 and an m, and we would be left with 2m squared divided by 2m is just m. 12m divided by 2m is 6. Okay? Now, on the negative 1m minus 6, there's not really a GCF. There is a leading coefficient of negative 1, so if you factor that out, you would be left with m plus 6. Well, notice that m plus 6 is what we're left with in both cases. So if you pull out a factor, a GCF of m plus 6, if you literally pull that out, you're left with 2m minus 1. So m plus 6, 2m minus 1. And then, like, I mean, there's a factor of 1. I mean, not you don't have to write that there. But now, what cancels? The m plus 6 and nothing else. The 2m plus 1 and the 2m minus 1, while they do look similar, factoring out a negative wouldn't make them the same. So our final answer is 2m plus 1 divided by 2m minus 1. So number 10, it's a lot like number 9, except, so I mean, we do need to view that 4y plus 3 as being over 1. The only thing is, this is a division problem, so you need to rewrite it and flip that 4y plus 3 over 1 to say 1 over 4y plus 3, like this. So once you're here, we're really worried about factoring that trinomial. Well, I mean, we need to see if everything factors. But the trinomial of 4y squared minus 3, I'm looking for what multiplies to give me negative 12, because 4 times negative 3 is negative 12, but adds to give me negative 1. If you're multiplying to get a negative, the signs are different. If you're adding to get a negative 1, the larger number is negative. So what about negative 4 and positive 3? So rewrite that trinomial as 4y squared minus 4y plus 3y minus 3. And now we can factor by grouping. I can pull out a 4y and be left with y minus 1. I can pull out a 3y, or no, I can just pull out a 3 and be left with y minus 1, so that you can then pull out a y minus 1 and be left with 4y plus 3. And you don't have to write those factors in any particular order. Now on the bottom, the 3y minus 3, I can pull out a 3 and be left with y minus 1. And we also have the factor right here of 4y plus 3. So there's a good bit of cancellation that happens. On number 11, we're dealing with another division problem, so I'm going to rewrite it and flip that second rational expression. So once I've done that, I'm ready to see what factors. So the trinomial of a squared plus 3a minus 18, factors of a negative 18 that add to give you a positive 3. Positive 6 and negative 3 work. They multiply to give you that negative 18, but add to give you a positive 3. The a plus 5 doesn't factor. Then in the bottom, a squared plus 13, a plus 40, factors of 40 that add to give you 13, 8, and 5. And then we have the a minus 3 right here. So a minus 3 cancels. A plus 5 cancels, and that's it. So we're left with a plus 6 divided by a plus 8. So now on number 12, we need to factor the numerators and denominators. The 4-term polynomial right here, I'm going to factor by grouping. I can pull out an a and be left with x minus 1. And then I can pull out a 2 and a b and be left with x minus 1. So that will factor into x minus 1 times, if you factor the x minus 1 out, you're left with a plus 2b. Now, this trinomial, the factors of 4 that add to give you negative 4 would be negative 2 and negative 2. So if we turn this into a 4-term binomial, a 4-term polynomial, and say instead of negative 4, we say negative 2 minus 2ab, well, then that's the same thing This is the same thing as negative 4ab. So now that's a 4-term polynomial that I can factor by grouping. Pull out from the front, pull out a b, and be left with b minus 2a. And then from the back binomial, pull out a negative because your leading coefficient is negative, meaning the front number, so negative 2. And then pull out, we can pull out a 2. We can also pull out an a. And then if you say negative 2ab divided by negative 2, you would be left with b. And 4a squared divided by negative 2a is negative 2, and a squared divided by a is a. So that factors into b minus 2a. If you factor a b minus 2a out from both, you would be left with b minus 2a there as well. Now on the bottom, a squared minus 4ab, there's not a GCF, but that is a difference of squares. The square root of a squared is a. The square root of 4 is 2. The square root of b squared is b. And now 3x squared minus 3x, I can pull out a 3 and an x. And if you pull out a 3x, you would be left with x minus 1. So what cancels? A factor of x minus 1. Factor of a plus 2b, and that would be it. I'm looking at the b minus 2a's in the top and thinking how similar that looks to this down here, but they're just not the same. So that would be b minus 2a squared in the top, because there's 2 of those, and 3x times a minus 2b in the bottom. On number 13, don't let that trip you up. We're just going to rewrite the middle. We're going to flip it, and then the whole thing will be a multiplication problem. So the only thing that we did, we just flipped that middle part, and everything else stayed the same, because what's immediately behind that division, that's what gets flipped in order for it to change to multiplication. So one big fraction, we're going to make sure we factor everything out. This would be factoring by grouping right here. If you pull out a b, and actually let me look, I wrote that down wrong. So if this is a b squared, so if you pull out a b, you can pull out a b squared, you would be left with b plus 2. And over here at negative b minus 2, there's not a GCF, but the leading coefficient is negative, as in the front thing is negative. So if you pull out a negative 1, you would be left with b plus 2. So now if you pull out a b plus 2, what you're left with is b squared minus 1. So that's factored, except b squared minus 1 is a difference of squares. Okay, let's look at 2b squared plus 5b minus 3. We're looking for what multiplies to give us negative 6, and what adds to give us that positive 5 in the middle. So you could say 6 times negative 1, that's negative 6 if you multiply, and it's positive 5 if you add them. So let's see. I could rewrite this trinomial as a 4-term polynomial that said 2b squared plus 6b minus 1b minus 3. Okay, and let me just come off to the side and do that. So again, I'm sorry, it's a positive 6 and a negative 1, because the positive 6 and negative 1, they would add to give me that positive 5b that was originally in the middle. And so now that it's a 4-term polynomial, I can factor by grouping, and the front has a 2 and a b in common, and if you factor out a 2b, you would just be left with b, because 2b squared divided by 2b is b, and then 6b divided by 2b is 3. Negative b minus 3, you can pull out a negative because your leading coefficient is negative, and you would just be left with b plus 3. So that factors into, if you take out that b plus 3, you're left with 2b minus 1. Now, the 3b plus 6 right here, if you factor out a 3, you're left with b plus 2. Now in the bottom, factors of 3 that add to give you 4, 3, and 1. b squared minus 4 is a difference of squares. Four b squared minus 1 is also a difference of squares. So let's see what cancels. The factor of 2b minus 1, b plus 2, b plus 1, b plus 3, and I believe that's it. So that would be 3 b minus 1 b plus 2 all over b minus 2 times 2b plus 1. So when I'm rewriting this one, remember anything behind that division sign gets flipped whenever you change it into multiplication. So when I change it into multiplication, I'll change that into p squared minus 16 divided by, and I'm trying to write my 6's better, 16 minus, divided by p squared plus p. And then this one flips as well. It becomes 10p plus 40 divided by 4p plus 4. So let's factor everything out. P squared plus 3p. I can take out a p, be left with p plus 3. P squared minus 16 is a difference of squares. 10p plus 40, you can factor out a 10. And remember, 10 is 2 times 5. And if you factor out a 10, you're left with p plus 4. Factors of 12 that add to give you 7. P plus 3. P plus 4. 3 and 4. I can factor out a p from the p squared and the p right there, so that I would be left with p plus 1. And the 4 and the 4p plus 4, I could factor out a 4, which is really 2 times 2. And if you factor out a 4, you're left with p plus 1. So what cancels? Factor of p plus 4, factor of p plus 3, factor of p, factor of 2, and that's about it. So that I'm left with 5 times p plus 4 times p minus 4, all divided by 2 times p plus 1 times p plus 1.